Everyone, welcome to the lectures of the elementary processes of elementary principles of the chemical processes. Right. Okay, as usual, let's have a quick recap about what we have learned on Monday. On Monday, we start from the beginning of the chapter 3, and then we start to learn mass and volume. So so we understand the mass value with density, then we know that you will be able to find that the conversion factor is that density, right? Conversion factor. So you know that the specific value is the reciprocal of the density, okay? And specific gravity, you understand that, right? Okay, so how about the thermal expansion? Thermal expansion is the, if we increase the temperature, the value increase in a general case. So the density will be decreased, right? Okay, so, and after that, we move to a very important part of this in the chapter 3, which is flow rate, right? So we understand there's a there are two flow rates you need to learn. One is called mass flow rate, one is the volumetric flow rate. Okay, so the mass flow rate and volumetric flow rate, the conversion factor is what? It's density, right? Okay, so you understand this is called rotameter, and rotameter is to measure the volumetric flow rate. In order to change from volumetric flow rate to mass flow rate, what you need is the density of the fluid, right? Okay, so you need to know how to do the conversion, and you also need to know this is called rotameter, and this is the flow rate measurement device. Okay, so this is very easy, and then and after that we go to the section 3.3, which is a chemical composition of the fluids. It can be in a gas phase, it can be oxygen, nitrogen, carbon dioxide, or helium, for example. So you need to know how to address the composition. Okay, so first of all, we learn moles and the molecular weight. Remember? So for the mass mole and molecular weight, the conversion factor is molecular weight, right? From the mass to mole. So we know that just now we understand in order to convert from the volumetric flow rate to the mass flow rate, the conversion factor is density. So from the mass flow rate to the molar flow rate, the conversion factor is molecular weight or atomic weight, right? Okay. Right. So this is another topic, is that if you have a mixture and you need to know the fraction, and you need to know the average molecular weight by mass or by mole. Okay, so this is the summary of the chemical composition. So you understand that the concentration is always divided by a volume. So when we talk about the composition, it's a kind of big scope. So there's a small portion is called concentration. So everything if you want to talk about concentration, everybody will think, or something divided by volume. Okay, so we have a table. I remember I have a table showing you here, and there's a special case which is molarity, right? Remember this on Monday? So the last part of this section is called part per million and part per billion, and this is a dimensionless quantity, right? So once you want to talk about the concentration, or you want to talk about the composition in gas phase, so what you need to use is what? Is weight or mole. Normally use mole to represent the ppm or ppb in gas phase. If you talk about liquid, So normally you use weight to represent ppm or ppb. So you know ppm is part per billion for short, right? ppb is parts per billion for short. Okay? Right, so that's all you have learned on Monday. So today we go to the last part of the chapter 3, which is pressure and temperature. So you know, pressure and temperature, you need to know how to define the pressure and how to measure the pressure. Again, as well as the temperature. You need to know the definition of the temperature. You also need to know how to measure the temperature as an engineer. So today we are going to talk about, we start from the pressure first. Okay, so there's two terms in our lecture today. Is the first one is called fluid pressure, and the second one is called hydrostatic head. Hydrostatic head. So what is pressure? If you have a container and you have molecules inside, okay, and then you have temperature. So molecule will be very active and hit the wall. So pressure is exerted by particles collisions inside a closed container. So this is a container. So what's the definition of pressure? Pressure is the force divided by area. So this is the definition of pressure. I'm sure you learned this before. So assume there is no molecule inside this container. What's the pressure? Pressure will be equal to 0, right? If there is no molecule in this container, there's no pressure at all. But in the reality, it's very, 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 very difficult to make a space which has no molecule inside. Okay, so normally the pressure is related to the molecule in gas phase. Okay, so how about if this container, the temperature in this container is 0 Kelvin? Is any pressure in this container? No? Yes or no? If the temperature is 0 Kelvin and there are one more of the oxygen inside this container, but the temperature inside is 0 Kelvin, can you tell me the pressure? No pressure, right? Why? Because all the objects reach the temperature at 0 Kelvin. Everything doesn't move. So there's no collision. There's no collision. So pressure will be 0, absolutely 0. But can you reach 0 Kelvin? No. In reality, it's very, 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 I will say maybe impossible to reach 0 Kelvin. Okay? I'll tell you why very soon. Okay, so the pressure, the definition of pressure is force divided by area. Okay, so for the different dimension or different system of unit, like SI system, we use Pascal. We use PA for short, right? You understand the PA, and CGS is bar, the dyne per square centimeter. Okay, so American engineering system, we use pound force per square feet, and here we use PSI for short. So the PSI is pound per square inch. Okay, pound per square inch. Okay, so you can use Pascal, bar, or PSI. And then once you use Pascal, you know, oh, wow, this is SI system. So the unit is Newton per square meter. And this bar is dyne per square centimeter. Something like this. Okay? Right. So the second term is called fluid pressure. So when the first term is called fluid pressure. When you have fluid, it flows from the left if you have a pipe, the water flow from the top to the bottom. And if you have a hole here, you drill a hole, and then you have a stopper to stop it, right? So once you take out the stopper, the water will come from the hole from the pipe, right? So you need to stop it, right? You need to stop the pipe. So the force you use and the area, the whole of the area is measured, so you can get the pressure. Okay, so this is called fluid pressure. Fluid pressure. And the second thing is called hydrostatic pressure. This is fluid, right? And then this is the liquid or the fluid stay here. So once you want to measure the pressure from the top, from here to here, so you understand this is called hydrostatic pressure. Hydrostatic pressure, for example, this is sea, your river, and then you have the ground. You have to measure the pressure in the river. So this is the pressure here will be equal to the pressure from the air and to the pressure from the liquid. Okay, so I'm sure you learned this when you are in junior high school. Right, P equal to P0 plus rho GH. Rho is what? Density, right? G is gravity. H is what? Is the height. Okay, so this is very easy. This is very easy. So now we want to know what's the atmospheric pressure and what's the head. So you might say, well, Professor, sometimes I learned something different when I was in high school, when I was in junior high. So the pressure P is what is equal to ATM. What is ATM? ATM is, I'll tell you later. But what ATM is that 14.7 psi. You just learn psi, right? This is American engineering system. So at this moment we have 1 ATM in this atmosphere, generally speaking. So the pressure in terms of American engineering system, the pressure will be 14.7 psi, and we can call it 1 ATM. But you know, well, Professor, this is not what I learned. What I learned is 1 ATM equal to 760 millimeter mercury. Right? You learned this, right? So 1 ATM equal to 760 millimeter mercury. Right, so this is the unit of the pressure. But this is not the unit of the pressure. This is the length. Right? Millimeter is a kind of length. Distance. So this is not equal because the unit is not the same. But sometimes we use this 760 millimeter mercury to represent 1 ATM. You understand, right? But the value can be converted. But the unit is not the same. Dimension is not the same. But we get used to this. We get used to this. So what can we do? So somehow we use head. Okay, to represent pressure. But the head, this is the length of this is the unit of the length. This is not the unit of the pressure. Okay, so please remember this. So 14.7 psi equal to 76 centimeter. Of course, is 760 millimeter mercury. So why is 760 millimeter mercury? If you have 76, if you have a millimeter, if you have mercury and the height of the mercury is 76 centimeter, that will be called 1 ATM. Okay, that will be called 1 ATM. So this is H is here. Rho GH, remember rho GH. If you use the mercury, if you use the density of the mercury, and this will, if this is 1 ATM, this will be 76 centimeter. Okay. So this is the exercise for you to do a very simple calculation. Okay. So again, I don't want to waste your time. Please read this by yourself. So far we learned something like Pascal, which is SI system, right? Bar is CGS system, and then ATM, right? ATM is called standard atmosphere. And then we also learn pound per square inch, right? We use PSI, remember? Okay, so we already learned 1, 2, 3, 4. How about torr? I don't know you have seen this or not. Torr, remember? Torr is, when we say 760 millimeter mercury, this is torr. So 1 ATM is 760 millimeter mercury, is what we call 760 torr. So for the conversion factor of how to convert all the things together. So another one is technical atmosphere, we call AT. We don't sell them, we don't use this often. So what you need to know is this one, standard atmosphere, torr and pound and PSI. Okay, so this is the conversion factor. So 1 par is equal to 1 Pascal, right? Okay, but 1 pi is equal to 10 to minus 5 bar. That's why you know. So one, for example, this is I mark in red color. Here is 1 bar is 1 Pascal, right? 1 par, this is 1 bar here. Okay, and this is 1 ATM here. Okay, and then 1 torr here, millimeter mercury. Okay, so how do you do the conversion? 1 psi equal to 5171 torr. Okay, something like this. So please remember, you don't need to remember this, but you need to remember once you need to find out how to do the conversion, Google it. Okay, and you know this is the torr is a unit of the pressure, and the psi is a unit of the pressure. That's all you need to know. And then once you need to know the conversion, take this slice and then you Google it. I'm sure you will be able to find it very easily. Okay. So now this is another exercise. The pressure below the surface of the fluid. So that's what you need to know. They want to ask you what's the pressure here. If you have water, which is 30 meter water, and then you need to count by atmospheric pressure, and you need to count by the water pressure. Again, please practice this by yourself. Right. So now let's move to another topic, which is 3.4b, atmospheric pressure and absolute pressure and gauge pressure. What is atmospheric pressure? Atmospheric pressure is 1 atm. When we stay here, it's roughly 1 atm, which is 760 millimeter mercury, right? So why this number? Because we understand we have gravity, right? All the molecules were trapped by this gravity. So when you go out to this space, the pressure is almost zero, because there's no molecules, or very few molecules. Okay, so once the molecules were trapped in this area, and you start to count from here to here, because you stay on the surface of the Earth, right? In this planet. So surface of Earth, you stay in the surface. So you need to count the pressure from here to here and accumulate. And then once you get a pressure here, so this is called atmospheric pressure. Easy. So you got an average. So this is what we call sea level. So it's low GH. That's easy. And you need to know the average density of this air, and then gravity and the height. That's all that's the pressure you get. Okay, and that's this about 760 millimeter mercury. Right, this example is telling you that x-axis is atmospheric pressure with ATM, and you have if you are in a sea level, that's 1 ATM, and this y-axis is the the height, right? Elevation, which is meter, unit is meter. So if you stay high in a higher mountain, the pressure is getting less. That's for sure, right? Because you have less air above you, right? On the top of you. So this is sea level. Where is Denver? Denver is Denver is here in the United States, somewhere in the middle. So Denver is the elevation is about 200 meters, right? So the pressure is about 0.83 atm. How about this city, La Paz, Bolivia? Bolivia is somewhere in the South American, right? South American, and then it's 0.66 atm. Once you go to the highest mountain, okay, Mountain Everest, so you got the pressure which is very low because you have less air. Okay? Right. So now we understand what's the definition of atmospheric pressure. And then now let's learn another terms called absolute pressure and gauge pressure. What is absolute pressure? Remember when I talked to you about a container and there is no air. There's no air. And or the temperature reached to 0 Kelvin. So the pressure is 0. And this is what we call absolute pressure is equal to 0. Okay, so this is Bourdon gauge. This is the kind of gauge I'm going to show you very soon. This is PSIA, right? PSIA. The PSIA is pound per square inch, right? A is what? PSI, you know that, right? Pound per square inch. What's A? A represents absolute. So this pointer or this indicator telling you that if this pointer reaches to 14.7 and then this is called absolute pressure, the pressure is what? 14.7, which is atmospheric pressure. Okay? So you might say, wow, Professor, this is easy because if the indicator or pointer go to 0, it's vacuum, right? The pressure is 0. Okay, so what happened to gauge pressure? The gauge pressure is that we regard at this moment the pressure is 0. So that's why we call gauge pressure. So the gauge pressure, this is the gauge pressure. This is PSIG. G is stand for gauge. So once this is different type, two different units, two different name, which is absolute, and this is gauge. So when you have, this is called Bourdon gauge, this is gauge. So the first thing you got is, you need to see this is PSIA or this is PSIG. So why is G? Because if the gauge pressure telling you that at 1 atm, the measurement will go to 0, will be 0. So what you can see is that, so if you might say, well, Professor, if the atmospheric pressure is 0, indicator go to 0, then what happened to the vacuum? That will be minus, right? Minus 760 millimeter mercury. So this gauge important is to see this is gauge pressure or absolute pressure gauge. So when P sub ABS is absolute, right, is equal to 1, then the gauge pressure will be equal to 0. So this is what? This is gauge pressure, right? This is gauge pressure. So the absolute pressure will be equal to gauge pressure plus atmospheric pressure, because atmospheric pressure is 1, right? Okay. You might say, well, Professor, why bother this? Why we need to have this kind of thing? Why we can just have one gauge, or one pressure gauge only? The reason is that because of the design of this. Okay, that's why I want to tell you here is that gauge pressure and absolute pressure is the difference between gauge pressure and absolute pressure is only 1 atm. So what you need to remember is this only. Okay, this is the figures showing you that this, for example, this absolute zero pressure and this for atmospheric pressure. Okay, so if you have atmospheric pressure, the pressure above atmospheric, that is the pressure below atmospheric. And you have two different types of gauge. The gauge one is absolute, to measure absolute pressure, which is PSIA, or you have bar sub A. It goes up. This is called absolute pressure, right? So it goes up, absolute pressure, and it goes up, and then goes up. So it goes up and goes up, goes up. Okay. So when you have this kind of gauge, and gauge indicator go to 0, and this here is open. So you understand that now this gauge is this Bourdon gauge is for measurement of the gauge pressure. So this one is for the gauge pressure. It can go up, it can go down. But this one only can goes up, right? Okay. Right? And another term is called barometric pressure. It's measured for the atmospheric pressure only. Okay, so don't worry about this. What I want to tell you is there are two different types of the gauge. And one is to measure the absolute pressure, one is to measure the gauge pressure. Right, once you remember this, and now I want to show you that how to measure the pressure using a tool. So you can find out this in, this is called Paris Chemical Engineering Handbook. This is the Bible of for the chemical engineer. But now you can just check most of the information in the internet if you want to. So the measurement method, the first one is, and also the most important one is called elastic element method. We call Bourdon gauge or Bourdon tube. Ladies and gentlemen, this will definitely in your midterm exam. This question will be definitely in your midterm exam, so please remember this. Okay, this is called Bourdon gauge, or Bourdon tube. What is Bourdon tube? I'll tell you later. But what you learn when you are in high school or junior high, you learn this, right? Liquid color method. This is what we call manometer. So you have a fluid, right? And you measure the pressure, A pressure and B pressure, and you got the differences of the pressure from A position to B position. This is called liquid color method. The third one is you can use electrical methods. When I was a PhD student, I started to use this, we call transducer. They use different phenomena, principles to measure the pressure. But I don't want to tell you this in detail. You can check this if you are interested in this. If you are interested to understand transducer, you just Google it. I'm sure you can find a lot of information about this. But this is more practical at this moment, so I want you to know this. It's called Bourdon gauge or Bourdon tube. So what is Bourdon gauge, Bourdon tube? I want to show you here is that this is this is called Bourdon gauge or Bourdon tube. As I can show you here, I want to show you. Can you see this? No? Okay. Good. This is what we call. Okay. So this is, you know, you have an indicator here, right? Let me make it bigger. What's this? Wait, focus. How can I make it big? Okay, this one. 几高？哎，几高？ Right, can you see this? Right, this is called Budong gauge, right? Can anybody tell me the unit of this? There are 2 units. One is called pound per square inch. One is, what's that? Inch mercury, right? So you have two different types. And what is this? Is another measurement. Okay, does anybody want to tell me, is this measurement for the absolute pressure or gauge pressure? Which one? A, absolute pressure. B, gauge pressure. 0.5 point. Raise your hand. Yes. A, right? A is what? I forgot. Huh? Absolute pressure, right? 绝对压力. Why? Thank you. That's correct. Why? Because this indicator can go to the vacuum, can go up to the higher pressure. And now, because, you know, now I didn't connect to anyone. This end need to connect to a pipe or to connect to anyone which has a pressure. And now it's open to the space. So the space is now is what? It's 1 atm, right? It's unintended, but indicator tells us it's 0. Well, it's not. It's close to 0. But so this is what you can measure the absolute pressure. You can measure this one. Sorry, is that right? Is this called absolute pressure? I'm sorry. Say again. 这是我用中文问啊，请问这是量大气压力？这是量绝对压力还是 gauge pressure? A gauge pressure, A absolute pressure, B gauge pressure. 再给你一次机会。这现在是空的哦，没有连到任何的地方去哦。Indicator is 0. So this is gauge pressure or absolute pressure. (很抱歉，可能没办法给你分数了。我刚才没有听清楚，它是要量的是 gauge pressure 哦，因为 because if this go to 1, what happened? This is 1, right? So 1, but absolute pressure will be 2, right? Absolute pressure will be 2. But this indicator is go to 1, that's 1 atm. But as a matter of fact, in the reality, when you want to do the calculation, that's 2 atm. Because what? Because this is minus here. Right. Okay. Anyway, so what I want to tell you is that when you see this, and you see in the back, there's a kind of, this is kind of a small box, right? Small thing, and there's something miracle inside. That's why you can measure the pressure, right? You can measure the pressure here. And then if we open it, we will see something which is very simple, but it's kind of genius. It's kind of designed very well. Okay, so let me let me show you. This. Okay, so this is the front, right? You can see that indicator here, and then if you turn it around and you open this box, you'll see something like this. And this is a tube. This is a tube we call Pudong tube. And this is called Pudong gauge. This is Pudong tube. The Pudong tube is kind of tube. There's nothing inside. Okay, so if you have a high pressure going to this tube, then what happened to this tube? If you have air going to this, 5 atm air or 5 bar air going to this tube, what happened to this tube? This tube will straight, will go this way, right? Because it's under the pressure. It's a bend Pudong tube will under pressure will become more straight, and this straight will pull this link. And to move this sector gear, and then the pineal gear will move too. You see that this sector gear, if this pull up, and the sector gear move to this way, right? And then the pineal gear will move this way. So the pointer will move this way. Okay, and if you have a scale like this in the front, so under the different pressure, this pointer or indicator will move around from here to here. Right? So this is what we call Pudong gauge. Pudong gauge. Right. So in your midterm exam, please draw this picture for me. Okay, easy. You don't need to make it very pretty. Okay? But at least tell me that the pressure going and this tube, this is one open end. This sealed tube. This is open. So pressure go in, this tube, it's Pudong tube, right? And this will go up because under the heavy pressure, and then this sector and the pineal gear will move, and the pointer will move. Okay? So let me show you a video so that I want you to have a better understanding of this Pudong gauge. Where is So what I want you to tell me is this page. I want you to know that the structure, the figures of this Pudong gauge, and I want you to know some information about the Pudong gauge, and you need to tell me this information, please, in your midterm exam. So this is kind of C type of tube, and one end is sealed, one end is open. And once you get the pressure, it's like whistle, right? You just hear from the video, and then you will move this to become straight, and then you can change. You can have he call it needle, or you can call it pointer. Yeah. And this is a very cheap measurement for the pressure, very cheap compared to the transducer I just told you. So, and very powerful. You can measure from 0 to 7,000 atm, which is very, very heavy pressure, very, very high. So it's cheap, and you can measure a wide range of the pressure. So this is very good design. Okay, compared to the manometer, you use mercury. See that? You use mercury to measure the pressure. The range is 0 to 3. It's not practical for the engineer to use. Okay, that's why Pudong gauge is very important. So I want you to remember. Right. So next one is called manometer. Manometer is easy, so I want to skip this. I'm sure you learned this in your high school, so I just skip this. Okay, so please. then another one is called barometer. Barometer is to measure the atmospheric pressure, which is barometer. For example, if your experiment is related to the pressure, and then you need to measure the pressure very precisely, especially atmospheric pressure, then this is the barometer you need to use. When I was a PhD student, I need to measure the pressure, and I need to be very precise about the atmospheric pressure. So I have this in my laboratory. So every time when I do the experiment, I need to measure the atmospheric pressure first, because today it might be high atmospheric pressure, today it might be low, but generally it's about 1, right? Okay, so there are some exercise. Okay, so please do this by yourself. Okay, so next topic is temperature. Before we go to the topic of temperatures, let's play Kahoot first. The temperature. So in chapter 3, there are 3 important tools you need to know. One is to measure the flow rate, which is rotameter. The second is the measurement of the pressure, which is Bourdon gauge, right? And now this is number 3, which you need to measure the temperature. So flow rate, pressure, and temperature. There are 3 important topics you need to know in this chapter. Okay? So what is the definition of the pressure, of the temperature? So the temperature of a substance in the particular state of aggregation, temperature can be measured in solid, can be measured in liquid, can be measured in a gas. Is a measure of the average kinetic energy. You need to remember kinetic energy possessed by molecules of the substance. So, for example, now the temperature in this room is 25 Celsius. So 25 is a kind of indicator to tell us this room is hot or cold. It's an indicator. And then 25, this number is the average kinetic energy of the molecules in this room. Listen, this is average. So you have a maximum, you have a minimum, right? It's a kind of distribution. Probably in this area that might be 20. In the center might be 25. In the end might be 30. Or here might be 10 or 0. So this is the kind of average. So all the molecules move and they have different kinetic energy. So you just add up all the molecules and then you do a kind of indicator, which is a temperature. Okay? So this is what you need to know. So as I just told you, because we measure the average, right? So it must have a distribution. So what's the distribution of the molecules in this room? So there are 2 types. I want to introduce to you. There are 2 types of the distribution. One is called normal distribution, or we call Gaussian distribution. This is called normal distribution. For example, if I give you midterm exam or final exam, you have there's some students get a very high score. Some students get a very low score. But average, you get in the middle. The most of the students doesn't get very high or doesn't get very low. So this is called normal distribution. Okay? So we can regard this as kind of very normal. We also call this bell curve. This kind of bell curve. For example, SAT is American term. You can regard any scores like midterm exam scores from students. So this is called Gaussian distribution. However, in this room, all the molecules behave different from the Gaussian distribution. They behave like Boltzmann distribution. So the Boltzmann distribution is like this. So this is molecular temperature, or you can regard this as a speed or kinetic energy. And then this is distribution, right? So this is what we call well curve. 金鱼 well curve. Okay, so it's not like normal distribution. So some of the molecules, the temperature is very, very high. Some of them is very low. But you can get, this is the mean, this is the maximum, right? And this is average. Average is here. Average for the Gaussian distribution is in the middle, right? But this is not. This is not in the maximum. This is average. So this is another term, so called root mean square. Okay, this is another definition. So this is called well curve. And then the molecule in this chamber behave like this. Some of them here, some of them here, some of them here. So this number of the particles with energy, which is the temperature, represent the temperature. Of course, if you have different, you can have different curve with, if you have different temperature, like this, temperature low, temperature high, and temperature high. So the speed can represent the kinetic energy, right? So you have high temperature, you can go, the curve will go to this way. Okay? And of course, the different molecules will behave differently. Okay, this is oxygen, nitrogen, helium, and hydrogen. Why hydrogen goes like this? Because it's very light, right? It's you know, it can manipulate with the temperature. So why they have temperature? This is called thermal vibration. You know, this is a kind of protein alpha helix. This is kind of a section of the protein. It moves. Why it moves? Because this has energy. And energy represents temperature. So if temperature reaches to 0 surrounding this protein, this molecule doesn't move. So reach to 0 Kelvin. So the amplitude of this vibration increases with the temperature. The temperature increase, this move dramatically heavy or quick or wider. Okay, this is called thermal vibration. We'll talk about this in material lecture of the material science when you reach the second year. Anyway, so how do you represent temperature? We use Celsius, right? But in United States, they don't use Celsius, they use Fahrenheit. So Fahrenheit is different. And then you use, and then for the scientists, they use Kelvin. Okay, this is more scientific way to address the temperature. So as you know that this ruler, this scale is that the 0 here is called freezing point of water, and for the Fahrenheit is 32 Fahrenheit, right? For the Celsius is 0 degree, or for Kelvin is 273.15 Kelvin. And this is the boiling point, right? So how do you convert from Celsius to Fahrenheit? How do you convert Celsius to Kelvin? Conversion factor, right? Conversion factor. Okay? Conversion factor. So what I want to tell you is that there's another one called Rankine. We don't use this often, so just for your information. You don't need to care about this too much. Right. And another one is that Celsius Fahrenheit is the Fahrenheit equal to 1.8 Celsius plus 32. And you know Kelvin, right? Kelvin. I'm sure you know this when you are in high school, so I don't want to talk about it too much, but what you need to know is Fahrenheit equal to 1.8 Celsius plus 32. So how do you find out this equation? Easy. Please do this by yourself. So a degree is both a temperature and also a temperature interval. So once you know that Fahrenheit equal to 1.8 Celsius plus 32, and then the differences of the Fahrenheit is equal to 1.8 differences of the Celsius, right? Okay, because you remove this 32. So what does that mean? The conversion factor is 1.2. Okay? So once you change 1 degree of the Celsius, and then the Fahrenheit change to 1.8. So what I want to tell you is that, so the conversion factor is this. So I have a question for you. If Fahrenheit increase 1 degree and Celsius increase 1 degree, which one is hotter? Which one may you feel hotter? Celsius, right? Celsius. Why? Because if you move if you have increased 1 degree, and that means you increase 1.8 degree Fahrenheit. But if you increase 1 degree Fahrenheit, you increase 1 degree Fahrenheit. So 1.8 and 1, of course, Celsius is hotter. There's a joke. Say that if you feel too hot in Taiwan, okay, you go to the United States, it's cold, it's cooler. Why? Because they use Fahrenheit. Okay. Oh, sorry, I made a mistake. If you go to United States, you go to a Celsius, which is colder. Right. So I just want to. So this is the exercise. Please do this by yourself. And then this example, I want to show you this example. This is the heat capacity at a constant pressure. We use C sub P. And this is C sub P is that once it increase 1 degree, the temperature, what's the need of the energy you need for an object. So this is what we call Cp. P is a constant pressure. We have a Cv. V is constant volume. But you don't need to worry about this at this moment. So what I want to tell you is that the Cp for ammonia is equal to this. Cp is equal to 0.487 plus 2.29 times 10 to minus 4. T is here is Fahrenheit. So you understand Cp, this is the unit of Cp, this is the value of the Cp with the temperature. So what you need to know is that this is American engineering system. Right? This equation is for the American engineering system. However, if I want to ask you to change to CGS system, or I want you to change the joule per gram times Celsius for me, can you do that for me? Okay, so the key is you need to change this to this from both sides. And as I just told you, this is the unit, this is the volume. So what you can do is that you have to change this to here, you have to change this to this. Right? Right? Okay, so how can we do that? For this is unit. On the left hand side, this one, you change to this. And what you need to know is find a table and got the dimensional equation from BTU and change to what? From BTU change to joule. And you know that this conversion factor is 1 joule equal to 9.486 times 10 to minus 4 BTU. So you can find this in the table and you can change to BTU to joule, right? BTU to joule, and you can change it from the pound mass to the gram. 1 pound mass equal to 453.539 grams. And you need to change to this Fahrenheit to Celsius. So 1 Fahrenheit equal to 1 Celsius equal to 1.8 Fahrenheit. You might say, well, Professor, this is not correct. 1 Fahrenheit equal to 1.8 Celsius plus 32, right? Why you use this? Because this is conversion factor. This is talk about unit only. And unit only, this is a conversion factor. So remember, conversion factor is not 1.8 Celsius, 1 Fahrenheit equal to 1.8 C plus 32. That's the equation. This is the conversion factor. Okay? So left hand side, you use volume. So left hand side here, this is volume, right? So this Fahrenheit, you can put this number here, 1.8 Celsius plus 32. So as a result on the left hand side and as a result on the right hand side, you get it together. So you found this is the answer. So Cp equal to 2.06 plus 1.72 times 10 to minus 3. T is Celsius. Okay, so this is volume, this is unit, this is volume. Don't miss out. Okay? Right, so this is the history of the Fahrenheit and Celsius. Again, please, if you are interested on this, please read this. Right, when I was in United States, somebody told me that's an easy way to do the calculation between Celsius and Fahrenheit without just one Fahrenheit equal to 1.8 Celsius plus 32. How to do that? It's easy. You can count this by yourself. For example, first of all, you subtract from Fahrenheit to Celsius. You know, when I go to the United States a few years ago at Stanford University, I don't know, 52 Fahrenheit is cold or warm. Should I wear heavy jacket or should I wear a t-shirt? I don't know. 52. So I had to do the calculation. One Fahrenheit equal to 1.8 Celsius plus 32, right? So you don't know 52 is Fahrenheit is cold or hot. But this is easy way. So first of all, if you have 80 Fahrenheit and you subtract 30 from the temperature, so 80 minus 30 becomes 50, right? 80 minus 30, easy, right? And then you divide it by 2. This 50 divided by 2, that way 25. And then if this number is only one digital, that means you plus 0. If it's about 10 to 19, you plus 1. If it is 20 to 29, you plus 2. So this is 25, right? So you plus 2. So 25 plus 2, that will be 27. So when you do the precise calculation using this equation, the answer tells you 26.6. So it's very close. So I know, wow, 80 Fahrenheit is 27. So I can just wear t-shirt or shirt. It's not too hot, it's not too cold, right? So if you go to the United States, this is a very easy way to let you find out what's the temperature. Okay? How about this? If American come to Taiwan, if your friend from American come to Taiwan, he say, wow, it's 12 degrees cold or hot. He need to wear jacket or he need to wear t-shirt, 12 Celsius. He has no idea or she has no idea. So the way is that you work it backward from this to here to here. So this one is 12 is about 10 to 19, right? So here you plus 1 and in this case you minus 1. So 12 minus 1 will be 11. Okay? And 11 here divided by 2, right? You times 2. So 11 times 2 will be 22. Okay, divide by 2 and that will be 20. That will be multiplied by 2, that will be 22. And 22, you have to subtract 30, right? And now you add up 30. 22 add up 30, that will be 52. So when you do a calculation using this equation, the answer tell you is 53.6. It's not much different. So 52 is good. The information of 52 is good enough for your friend from the United States to know that today the weather is cold or today the weather is hot. Okay? Just for your information. Wow. Now let's talk about the measurement of the measurement method. There are 4 things you can do it. One is thermometer. Thermometer is this one. Right? You know that because the temperature increase, the volume increase. So this value increase, so you got the level, higher level. So they indicate the scale tell you that the temperature increased. And this is, but we don't use this because this is, you can just measure a very narrow range. You cannot measure like 300 Celsius or 4,000 Celsius. But ladies and gentlemen, this is a good one, thermocouple. Thermocouple can let you measure 1,000 Celsius. Okay, that's what I'm going to tell you now. And number 3 and number 4 is called pyrometer. Use the ray using the radiation to measure the temperature. You know, you have, when you get fever, you have, you know, you can use this thermometer to measure your body temperature, or you can use pyrometer to measure your body temperature from a doctor, right? If you go to clinic. Okay, resistance of thermometer, that's another way. But what I want to tell you, what I want to introduce you here is called thermocouple. What is thermocouple? Everybody know this? Before we talk about thermocouple, this is Galileo thermometer. Galileo thermometer is the same. You contain a different liquid. If you go to the toy shop, you can see this, right? You can see this. Let me show you. So this is Galileo thermometer, right? So you have a different type of liquid with a different density. So you can get the temperature here. So the temperature here is, you want to see is that it got balance here, so you can read the temperature here is what? No, I get old, it's 22. Right. 手机不要用太多，是不是？哦，会提早得老花眼，我现在就老花眼了。OK， 好。另外呢，会得白内障，是不是？所以不要在晚上，在没有灯光的地方用手机，你的瞳孔会放大。你的瞳孔放大是什么意思？就把大部分光 suck 到你的蛋白里面，你的蛋白就被煮，你的水晶体就被煮熟了，那叫水晶，那叫做白内障。你就换你的年轻，不要太年轻就换这些东西了。Okay, sorry in Chinese. Okay, anyway, this thermometer, but that's not the point. The point is I want to let you know the thermocouple. Thermocouple is this. This is the meter to, this is thermocouple. And you plug into this meter. And because of different voltage, this is the temperature will convert to the different voltage, different level of voltage. And different voltage tell you the temperature. So this is one of the this is the concept. This alloy, alloy, and this is another type of alloy, and the two alloy check together, and this point will get different voltage. Under a different temperature will give you different voltage, and different voltage will tell you will indicate the temperature. Okay, so this is the probe, the top of the probe. You can put it to anywhere where you want to measure the temperature, and then it get linear. This is K-type, bingo. So you can find an equation for this type. Once you got the equation, mathematical equation, you can predict the temperature, right? Even though you just have a 7 set of data, but if you got a linear equation, you found linear equation, you can predict any temperatures on this line. Okay? So what's the thermocouple? I want you to remember this, and I want you to repeat this to me. Or you can write in Chinese and show me in your midterm exam. So the thermocouple is an electrical device consists of the two different conductors forming electrical junctions at different temperatures. A thermocouple produces temperature-dependent voltage as a result of the thermoelectrical effect, and this voltage can be interpreted to measure the temperature. So this probe and this go to a box or a meter, so you can get this. So it depends on different type of alloy. You can have different type of certain combination of the alloy have become popular as an industry standards, like type K, type T, type J, type M. Normally we use type K. Okay, type K. So type K is this. You don't need to remember this, but you need to remember this sentence. Okay, and you need to draw this picture for me to show me that what you understand. Okay, this is type K. The type K is that is the most common general purpose of a thermocouple with the sensitivity of the approximately 41 microvolt per centimeter per Celsius. So you increase 1 Celsius, this increasing 41 microvolt. Okay, if you increase 5, 41 times 5. So it's linear, and this is inexpensive alloy, and this can measure from -20, 200 Celsius to plus 1,350 Celsius, which is very good, right? Right. So this tells you the different type of the type, and then give you the. You can regard this. Most of them can regard this as a linear equation. Okay. So since I'm sorry I run out of our time today, I want to finish this, but unfortunately I don't have time. Anyway, so I think I better stop.